Most countries take longer than 38 months just to approve a planning permit. China built the world's largest train station in that time. That station is Chongqing East, and the numbers alone are enough to stop you cold. 1.22 million square meters of floor space, the equivalent of 170 football pitches. 2 million cubic meters of concrete. 366,000 tons of steel. 40,000 workers. A roof weighing 16,500 tons, spanning 120,000 square meters, the largest single-span roof structure in China. Grand Central Station is 6 times smaller. Europe's largest station is 15 times smaller. The platforms here are longer than the Eiffel Tower is tall, and it was built on a mountain. To understand why this matters, you need to understand Chongqing. This is a city where roads run above your head and trains pass through apartment blocks, not as a quirk, as a standard feature of urban life. The city earned its nickname, the 8D City, so when planners needed a site for a new megahub, they chose a mountain slope 20 kilometers from the city center. The city that runs trains through buildings decided to cut a mountain flat and build the world's largest station on top of it. April 2022. That mountain slope is where the story begins. Before a single foundation pile was driven, the machines moved in to do something no station project had ever required at this scale: remove an entire mountain. Every meter of that slope was mapped in 3D before a single cut was made. The earthwork alone took months. The rock under Chongqing is hard. The machines ran around the clock. Some sections needed blasting-controlled explosions. The mountain didn't give up its rock easily. This was one of the largest single-site excavations in Chinese construction history. Millions of cubic meters of rock removed. But cutting the mountain was only part of it. Once cut, the exposed face had to be held back with retaining walls along the full perimeter. The mountain wants its space back. Every drop of rain falling on the slope above flows directly to the site. Without a complete drainage system, the entire foundation would sit on saturated, unstable ground. Excavation, blasting, retaining walls, drainage, a flat platform on a mountain. Now the real construction begins. Before the first pile, the ground is tested. No assumptions on a mountain site. The foundation design is a forest of piles driven 20 meters into bedrock. Each pile starts as a rebar cage steel reinforcement installed before the concrete. Without it, the pile has only compressive strength, half what's needed. Concrete is then poured from the bottom up through a tremie pipe. Pour from the top, and the aggregate sinks, leaving the pile structurally weak. Every pile is load tested. A failure here is far cheaper to fix than under a completed building. Pile caps distribute each column's load across multiple piles. One column doesn't rest on one pile, it rests on a group. Ground beams tie every pile cap together, meaning one load anywhere on site is shared across the entire grid. The entire foundation is invisible below the surface. Every column, every floor, every passenger, all transferring load through those piles into the mountain below. With the foundation set, 8 floors of concrete begin rising from the ground. The process is repetitive by design. Formwork, rebar, concrete, cure, strip, repeated 8 times. 40,000 workers tying rebar by hand in full protective gear in Chongqing summer heat. Concrete generates heat as it cures. In Chongqing summers, it can crack from within. Cooling pipes run through the pores to prevent that, and there are no cold joints. A cold joint is a structural weakness created when a pore is stopped and restarted. Trucks arrive without pause. One continuous pore. Floors 1 through 5 carry the platform levels, metro connections, bus terminals, and taxi drop-offs. Floor 6 is the main concourse, the largest single space in the building, sitting 30 meters above the original mountain slope. Its edges curve. If the slab edge is wrong, the glass wall won't fit. Every curve is hand-formed. Floors 7 and 8 add retail and restaurants, a city layer stacked directly on top of a transport layer. 8 floors, open to the sky. The roof hasn't started yet, but the structure is there. The steel columns begin at 8th floor level, rising into open air above the concrete frame. 366,000 tons of steel arrive by road, sorted by crane, and sent upward in sections of 6 to 8 meters at a time. Each section is bolted, plumb-checked, then the next section begins. Every splice is torqued to the same specification. A single column carries 16,500 tons of roof. Every bolt matters. 40,000 workers don't do one column at a time. The entire forest grew together, cranes at every position simultaneously. These aren't ordinary columns. They branch at the top, mimicking the Chongqing city tree, the design inspiration for the station's shape. The branching arms serve an engineering function too. More connection points to the roof, better load distribution. Each finished column is covered in 1,200 stainless steel scales, each one at a different angle, each fitted by hand. Workers operated at 5 meters, 20 meters, and 35 meters on the same column, simultaneously fitting scales at the base while new sections were craned in at the top. Bare steel versus finished column, same object, transformed. All columns standing, branching tops ready. The forest of steel before anything covers it. Now comes the most complex single operation in the entire build, the roof. The problem is straightforward. 16,500 tons of roof structure, 57 meters in the air. No crane in existence can lift it directly. The engineers invented the solution specifically for this building. Build the roof on the ground, then move it to the sky. The roof is assembled at ground level. Every bolt torqued to specification, marked complete. One under-torqued bolt in a 16,500-ton roof, unacceptable. A rail system is installed at column head height. Multiple cranes raise roof sections simultaneously to 57 meters, with workers guiding placement by hand signal, millimeter tolerance. The lift is rehearsed for weeks before the first real raise. Then, hydraulic jacks slide hundreds of tons of roof structure horizontally along the rails, moving it into final position like furniture. The weld follows. When it cools, that section of roof belongs to the building permanently, section by section, lifted, slid, welded, 120,000 square meters, piece by piece. The largest single-span roof structure in China. With the roof sealed, 1,200 tons of aluminum framing go in before a single glass panel. Each panel weighs 800 kilograms. Workers install them at height, in 40-degree heat, hundreds of individual lifts. When the glass wall closes, the mountain landscape floods into the concourse. The glass reaches 60 degrees in summer and drops below zero in winter. Expansion joints absorb that movement. Without them, it cracks. While 8 floors were rising above ground, a separate operation was running 30 meters below crews tunneling in from the city's metro network. 2 projects, 1 building, built simultaneously. Metro underground, high-speed rail above, connected by a single escalator. That connection is why the hub functions as designed. Inside the finished structure, 29 tracks required millimeter-level accuracy. At 350 kilometers per hour, imprecision is not an option. No ballast track here. Rails are bolted direct to concrete slab. They don't move, they don't settle, they don't need retamping. Every meter laser checked before fixing. Thermite welding creates one continuous rail, no joints inside the station. Catenary wire is strung at an exact height. Too high, the pantograph loses contact. Too low, it's damaged. The system compensates automatically for Chongqing's full temperature range. Platform screen doors are positioned to align exactly with train doors, 1.22 million square meters of floor tiling laid by machine. The HVAC system is sized for the hottest day ever recorded in Chongqing. The station runs its own substation. The sprinkler network is larger than the road network of some small towns. Smart LED lighting dims when daylight floods in through the skylights, compensating seamlessly at dawn and dusk. Testing begins while fit-out continues. Tracks are tested while shelves are being stocked in the retail floors above. Every signal is tested individually, then in combination no conflicting train movements can be authorized. Testing runs from walking speed to 200 kilometers per hour on approach, to full operational speed under real load. Every failure mode is tested before one passenger boards, not because failure is likely, because it cannot be left untested. The snag list reaches 0. In the 27th of June, 2025, blueprint to operating station, 38 months. The concourse fills with passengers on opening day. An airport check-in desk operates inside the train station. Your luggage goes directly to the airport, and you board a train. All 8 floors run simultaneously, every transport mode connected. After the last train each night, maintenance crews work across all 29 tracks. Maintenance is not optional. 3 months into operations, 16,000 passengers per hour, performing better than the most optimistic projections. The stainless steel scales on each column catch the light differently across the day. That was designed. The cranes that built the station have moved on to build the district forming around it. Station first, city follows. April 2022, a mountain slope. The 27th of June, 2025. The world's largest train station piles into bedrock, 8 floors, 4.1 meter tree columns, a 16,500-ton roof invented, built on the ground, and slid into position at 57 meters. A metro tunneled in while the floors went up, opened exactly on time. Passengers don't think about that, they just know this is where the train stops.